My name again is Willie Nsinikweli, who is going to take you through mathematics P4 class. Hope you are very fine over there. Before we get today's lesson, allow me to take you back to the previous lesson where we had some few numbers I left you with, and the instruction was change to improper fraction. Allow me to go through some of these numbers in the activity I gave you. You allow me to look at the first one, which was part A. I think they have given us two whole numbers and a third. Remember how the parts of mixed numbers or mixed fraction are. Remember we said this taking a numerator, this is a denominator, and the whole number. Therefore, we had to say we get the denominator times the whole number, then plus the numerator. This is all out of the denominator. Hope you are following what we had last time. Our denominator comes to be 3 times the whole number, which is 2. You should also remember why we put these brackets. What if I don't put them there? Here in P5 we shall tell you what we call the order of operations. We have multiplication, addition, subtraction, and division. So they have the order. So you find that multiplication in that order comes before addition. So our numerator is 1, and this is all out of the denominator, which is 3. Tables, 3 times 2, that is 6 plus 1 out of 3, and finally our answer gives us 7/3. Still, remind you that we call these fractions by their names. Not, yes, it is okay when you say 7 out of 3, but the name of this fraction is 7/3. Allow me to look at the last example, which was, the last part of our activity, which was part E. And part E was telling us to change 7 whole numbers and 5/6. If you check, that was part E. And the last one, we say this is our whole number, our numerator, and this is our denominator. So therefore we come and say it is a denominator times a whole number, then plus a numerator out of that denominator. In this case, our denominator is 6, and our whole number is 7, plus our numerator, which is 5, out of the denominator, which is 6. Hope you've already multiplied 6 times 7. 6 times 7, this gives us, somebody saying 42, plus 5 out of 6. What about if you get 42 and you add 5? Or somebody is saying 47 out of 6. In other words, this is 47/6 as our final answer. Hope if you followed the instructions and the examples I gave you before, and you compare only the 2 I've gone through, it will give you a picture of the rest of the numbers that I have not talked about, like part B, part C, and part D. Compare these, the examples, and what you have. You will get a clear picture. Okay? Hope you've organized your work as your teacher has tried on the chalkboard. For your case in the book, it is really the smartest. Not even smarter, but smartest. So, back to today's lesson, we have equivalent fractions. Everybody say equivalent fractions. Oh, let's ask ourselves. But before we go to equivalent fractions, let's look at the end of this lesson, what are you supposed to have learned? You must have learned what we call what are equivalent fractions to describe them. What are they? You also have to remember or to have got the examples. If I say examples, if somebody say equivalent fraction, can you give the examples? Or how can we find these equivalent fractions of a given fraction? Otherwise, we must know how to identify a numerator and a denominator. We shall find there multiplication of denominators alone and multiplication of numerators alone. Then we shall also see how these equivalent fractions are really equal. We shall also see that both in the diagrams and in the figures. Now, what are equivalent fractions? From the word equivalent fraction, you can get a short word, a very short word. Somebody is saying we can see the word equal. Very good. Before you go to the word equivalent, what is the word equal? What does the word equal mean? I remember a P1 teacher saying equal signs. Equal signs. 1 plus 1, it is 1 plus 1 equals 2. Therefore, when we say equal or equivalent, we are going to see the fractions that have the same value. They are equal in value. In other words, the definition of equivalent fraction, these are fractions whose value is the same. They can be 2, they can be 3, they can be 4, they can be more than that. But how can this one be done? Somebody is asking himself or herself, is fraction to be the same? Yes, you are going to watch. Remember what I have said? Equivalent fractions. Equivalent fractions are fractions whose value is the same. This is the simplest way I can describe that one. In other words, these fractions are equal. Ask yourself, how are they going to be equal? Just watch. Assume I have my diagram of this kind. This is a whole. If I ask you, tell me the shaded fraction here. P1 work, P2, P3. Now we are in P4. Somebody is saying, this is a half. Very good. One part is shaded out of the two. Another one can come here and draw the same hole, and he does this, and he does that. Then he shades the same side as you have seen here. Assume I have shaded this one. I'm asking the other one looking at me, watching this lesson, how many parts are shaded? Somebody saying 2. And out of how many? Somebody saying 4. The way I drew this one and the way I divided it, it is the way I have done here, but I have plotted the second division. This is here when you look at the shaded part here, which is this one, the shaded part which is this one, I'm telling you, this fraction is equal to this one. I may join another one. Assume I have again divided it like this, as somebody has watched. I have again does it this way. And again, I have done it this side. And I have again done it this side. But still, I want to show you that the part I shaded here, the same part I shaded here, I'm shading it again here. Okay? Now then, who can tell me the part that is shaded? We first count the total, my friend. We have 1, 2, 3, 4, 5, 6, 7, 8. These are all 8, okay? But how many have I shaded? 1, 2, 3, 4. Somebody saying 4. If you are watching, to be sincere, all these fractions are the same. A half, 2 quarters, and 4/8. These are equal. Why? when you consider the part I shaded here, it is the same part I shaded here, it is the same part I shaded here, but I was just dividing the holes. Okay? Hope you have watched this. I've said a half is equal to 2/4 is equal to 4/8. Okay? We can have other whatever diagrams, but this was just an eye opener that we can even draw more than this. But now let's look how we can find equivalent fractions. This time not by using diagrams, but in this case we can now use real fractions. Finding equivalent fractions. Finding equivalent fractions. How can they be found? Somebody say, hey teacher, how can they be found? Look. Take an example. Somebody is giving us the first example. The first example. Write the next two equivalent fractions. Equivalent fractions for let's have 1 out of 3. Sorry. Equivalent fraction for a third. Here we looked at the equivalent, two equivalent fractions that are equal to a half. But now it is a third. Remember this time, I'm not going to use diagrams. How do we find other equivalent fractions that are really equal to this a third? So here we shall have a third. We are going to multiply by other counting numbers. The next counting number after 1 is 2. But you can now not multiply by 1. If we multiply by 1 like this, I think this fraction will come back. So what are we supposed to do? We are going to leave 1 and go to the next counting number, which is 2. So here we shall have numerator times a numerator and out of a denominator times a denominator. Therefore, we shall have 1 times 2. This one gives us 2. What about 3 times 2 gives us 6. This fraction, 2 sixths, if I put it here to be sincere, a third and 2 sixths are equal when we go back this way. Teacher, what if I want to have the next, because they have said we give the next 2 equivalent fractions. The next, we are going to have, still I will bring a third. Watch. If I started with 2, the next counting number is 3. I multiply the numerator by 3, the denominator by 3. Here I started with multiply the given fraction by 2, and then by 2. I've said we can't start by 1. Why? It will give us again a third. So now 1 times 3. Somebody is giving me the answer. Somebody is saying 3. What about 3 times 3? Somebody is saying 9. So 3/9 is again another equivalent fraction for a third. These 3 fractions are really equal. Even if I can take you to diagrams, whether by calculation method, still they will give us those ones. We don't say that they stop here. They can be more than that. Are you getting me? We can have more, as many as we can. But according to the instruction, they have said, give us only 2 equivalent fractions for a third. If let's say somebody saying, find the next, somebody is saying 3 equivalent fractions. Fractions for, let's change and you have like 3/4. How can that one be done? We shall take the same method. 3/4. We are looking for other fractions that are equal in value as 3/4. Please watch and follow the examples properly. So we shall have our 3/4, as you can see. I said we shall multiply by counting numbers, the order of counting numbers. But I said we cannot begin with 1. Why? When you give 1, multiply by 1, multiply by 1, 3/4 will come again and we cannot write it again. Therefore, we go to the next counting number, which is 2. We multiply 2 by the numerator, then 2 by the denominator. Therefore, this gives us 3 times 2. Somebody saying 6. Good. Then 4 times 2. Yes, good. Somebody saying 8. So, 6/8 is equivalent to 3/4. So, we shall have 6/8. But they have asked us to find 3 of them. This is the first. Let's look for the next. The next equivalent fraction for 3/4, here we shall have 3/4 again, times the next counting number after 2, somebody saying 3. So multiply 3 by the numerator and 3 by the denominator. Okay? 3 times 3, somebody saying 9. Good. Out of, what about 4 times 3? Wow. Somebody saying 12. So now, you look at 9, 12. 9, 12. To be equal to the rest of these fractions I wrote before. Remember, the instruction is saying, please find the next 3. So far we have got 2. Please, allow me to move to the third and the last one, according to this example of ours. So we shall again go to 3/4 times the next equivalent, the next counting number after 3. Somebody said 4. Thank you so much. So we multiply 4 by the numerator, then 4 by the denominator. So let's multiply. 3 times 4. Wow! Somebody saying 12. Out of, what about 4 times 4? Oh, thank you so much. Somebody saying 16. So when you get 12/16 is also equal to our 3/4. I know you've observed very well the 3 equivalent fractions that I've given from this second example. I say equivalent fraction. Those are fractions whose value is equal, whose value is the same. As I started here, I'm still walking to the third and the last example, if you are to watch very well. Now, the third example, which I said the last, for those who are not paying attention, please look here. If I get the third or part C of our whatever equivalent fractions, someone will say, right. The next equivalent fractions, let's give at least a number of them. This time let's look for 4, but we shall be so fast. 4 equivalent fractions for this time. Let me put the simplest. Somebody saying put 3/10. Very good. For 3/10? Okay. Let's watch. 3/10. We have it here. We want to look for other equivalent fractions. They said, please give almost 4 of them. So we shall have our 3/10 times the first counting number is 1. But we have said we can't use 1. Why? It will give us back a 3/10. So let's begin with the 2 times 2, numerator and denominator. So 3 times 2, somebody is saying 6. Out of what about 10 times, that's the simplest, 10 times 2, very good. Everybody is saying 20. So we shall say 6 out of 20 is equal to 3/10. Let's go to the next. They want 4 of them. Please be patient. 4 of them. Let's go to the second one. They are saying it will be 3/10 again. Then times the next, which is 3 times 3. 3 times 3, someone is saying 9. Then 10 times 3, someone is saying 30. Thank you so much. This is 9/10. Sorry, 9/30. Okay? Follow me properly. We go to the third one, whereby we shall have 3/10 times 4 times 4. By numerator, we shall have 3 times 4 gives us 12, and 10 times 4 giving us 40. Very good. So we shall have to get here also 12/40th. Sorry. 12/40th is also another equivalent fraction for 3/10. Lastly, we are looking at the fourth equivalent fraction. The fourth equivalent fraction shall have 3/10, then times 5 times 5. When you multiply by the numerator, 3 times 5, somebody is saying 15. Then 10 times 5, this is 15. So we shall see also 50th is also another equivalent fraction for 3/10. You can see all these 1, 2, 3, 4, 5. All these 5 fractions are really equal in value. When you look at them, just their appearance may look different, but the value is the same. Hope you have been watching so good. When you take where we came from, equivalent is from the word equal, and something equal like something that is the same. But in mathematics, we look at the similarity in terms of value. Value. So, equivalent fraction, we said these are fractions whose value is the same, whose value is equal. We looked at these fractions in terms of shading. I think you were watching. Then I came to calculation. How do we calculate the equivalent fraction for a third? You multiply by the counting numbers apart from 1, because when you multiply by 1, it brings back a third. So we begin with the 2, we go to 3, we go to 4, like that. Here we found 2 of them, but I said they don't only stop at 2, they can be more than that. Like the next example, I looked for 3. The last example, I had to look for 4. Somebody can look for 5, can look for 6, can look for 7. So they don't stop somewhere, but they are endless if we are to look for them. I want to thank you for listening to me, and now get ready for the exercise, the simple exercise I will give you just only to find the equivalent fractions for the given fractions that I will give you. I want to thank you. Keep tuned.